Derivatives, basics of the derivatives. So derivatives is also, we study derivatives in under differentiation topic, and first we should know what are the basics of this. Like everyone knows the formulae, and then we can apply the formulae and get our answers, but getting answers is not the ultimate thing. First we should know what is a derivative. So here, to understand that, I have drawn a parabola, a quadratic function y equal to x square minus 4x plus 1. So if I have to find out the turning point of this curve, turning point means, like, if you can see from the left hand side when I am coming, in this graph by x square minus 4x plus 1, the graph is decreasing, the y values are decreasing. But as soon as I reach this point, which is called as the vertex of this particular function, after this vertex, my graph starts increasing. Yes, my value of the function starts increasing. So that is why this vertex, this is called as the turning point of this particular quadratic function. So finding out turning point of a quadratic function by plotting the curve, it's okay. You can see by plotting the curve, we can see from the graph and locate our point. But if we are not supposed to plot the graph, then we use completing the square method to find out the turning point. I have already made a video to find out the maximum and minimum point of a quadratic function, so you can go through that video and just revise it. So from completing the square method, we can find out the vertex, right? But what if my function is not quadratic? If my function is, say, something like this, y equals to x cube plus x square and something like that, so in that case, finding out turning point, we cannot do it by completing the square method. So in that case, we have to use some other method. What we do is, actually we find out the gradient. So we find out gradient, right? What do we find? We find the gradient of the function, gradient of a curve at a particular point, and that we find by plotting the tangent to the curve at that particular point. Like here I have plotted this quadratic function only, but if I am supposed to find out the gradient of my quadratic function at x equal to 3, so then what I will do, I will plot the I will simply draw a tangent at x equal to 3 point on the curve. Okay, and when I plot the tangent at this, I can find out the gradient. How? Like here you can see, if I move here 1 2, then I am moving 1 2 3 4 units up, correct? So if I am moving 2 units on x-axis, then I am moving 4 units on y-axis. What does it mean? That my gradient is 4 over 2. In this particular case, 4 over 2 means 2 is the my gradient at x equal to 3, right? So same way, if we have to find the gradient in any other point, like say at point 2, then we will have to plot a tangent like this. So you can see that at x equal to 2, the gradient is you can say x equal to 2, my gradient is 0 here, right? Because it is parallel to x-axis, so gradient is 0, right? So this way we can find out the gradient at any point by simply plotting or drawing the tangent at that particular point. So if I now just make a table of gradient and my x values, that at particular x, say at negative 1 0 1 2 3 4, so then I will be getting, say, my gradient. Let me write gradient as m here. So my gradient would be negative 6 at 0 negative 4. I have already calculated and then I'm writing it here. So 0 2 4. So this way we can see that this is the gradient of my curve at these particular points. Now we can easily see the relation. See, we have this is what? This is plus 2. This is again plus 2. This is also plus 2. So this is an arithmetic progression, right? This is an arithmetic progression here which we can see. So we can find out the nth term in this case. We can find out the nth term in this case. Remember, we do like it would be 2 times of n, since the difference is 2, so it would be 2 times of n. And when we do 2 times of n, first term is negative 6 here. So then what, or you can to say that first term if I take as negative 2, if I take first term as negative 2, in that case what we can do here, let us take minus 6 only here. So 2n would be what when n is equal to 1? Or let us first write these terms properly in this form, like n equal to negative 1, 0, 1, 2, 3, 4. Fine. And then my terms are what? My terms are negative 6, negative 4, negative 2, 0, 2, 4. Now we can see the difference is plus 2 everywhere, right? The difference is plus 2, because if I could have done it directly, so then there could be some problem in understanding the thing. That is why I'm writing it again. So I can write here 2 times of n now. So 2 times of n, which is like 2 times of negative 1 is negative 2, then 0, 2 times of 1 is 2, 2 times of 2 is 4, 2 times of 3 is 6, and 2 times of 4 is 8. Now what we have to add or subtract in this negative 2 to get negative 6? Negative 2 plus, negative 2, we have to get this thing, right? Negative 6, so I can add negative 4 to it. So I can say 2n minus 4. So minus 2 minus 4 would give me minus 6. 0 minus 4 would give me minus 4, right? So all these values we will be getting. Got it? It means what? That this is my gradient function, 2n minus 4. Here my n is x, so I can say that my gradient function we call it, and that is equal to 2x minus 4. For what? For x square minus 4x plus 1. Okay, so when our quadratic function is x square minus 4x plus 1, then for this particular function my gradient function is 2x minus 4. So if you have to now find out that what would be the gradient of my this curve at say x equal to, let us say at x equal to something point, let us say at x equal to 5, what would be my gradient? I can simply plug in x equal to 5 in this, and I will write 2 times of 5 minus 4, which is 10 minus 4, which is 6. So I can easily say that at x equal to 5, the gradient of my curve would be 6. Understood? So this is the basic of gradient thing. So now this gradient, which we normally write as m, okay, but now we will write this as dy by dx. Okay, what does it mean? Like if my function is this given by y equal to something like which we wrote x square plus 4x plus 1. So my gradient of this curve would be dy by dx. Okay, and we saw that our gradient was what? Our function is this minus. Okay, so our gradient is what? 2x minus 4. Our gradient is 2x minus 4. Fine. And this dy by dx is also denoted as f dash. Okay, so if I write my function fx is equal to x square minus 4x plus 1, then the gradient of this function is written as f dash x is equal to x square minus 4 is equal to 2x minus 4. Got it? So this is the thing. Now we can generalize the thing that in general, in general, if my function is y is equal to x raised to n, if my function is y equal to x raised to n, then dy by dx would be written as n times of x raised to n minus 1. Now this would be our general formula. This would be our general formula, and we can see here very clearly in this part that x square minus 4x plus 1 and dy by dx of x square when we are doing, so let us say d by dx of x square, so would be what? X square, so our n is 2, so it would be 2 times of x raised to 2 minus 1, right, which is 2x raised to 1, which is what? 2x. And then negative 4x if we have to do of negative 4x. So since negative 4 is constant, so that can be written as it is, and x raised to 1, so that would be what? 1 x raised to 1 minus 1, which is what? Negative 4 x raised to 0, and that is 1 only. So 1 into 1 is 1. So d by dx of negative 4x is negative 4. And d by dx, that is derivative of constant, would be 0. 1 is a constant number. It doesn't change, right? The constant number be as it is only. 1 means 1. 1 doesn't mean like 0.5 or 0.2. If I write 1, it is 1, right? It doesn't dwindles. So that is why derivative of any constant number would be 0. Whether it is d by dx of negative 12, negative 5, positive 5, it would be always 0. Hope this funda is clear, like basics of derivatives is clear. And now let us do few questions based on this. So if I have, say, y is equal to 4x raised to 4 minus 3x raised to 3 plus 5x square, and I have to find out the dy by dx or derivative of this function, or you can say we have to find out gradient function. See, I'm writing all. We have to find out, because question can be asked find out derivative, or they can ask you to find out the gradient function, okay, or they can write down what would be y dash, okay, it can be anything. But what we have to do, or they can ask you write the dy by dx of this. So what we have to do, we have to use this, right? So I will say my dy by dx would be what? Would be, for this 4x raised to the power 4, so this constant number 4 I will write as it is. Now x raised to the power 4, okay, so x raised to the power 4, so 4 power will come here because this is n x raised to n minus 1, so 4 x raised to 4 minus 1. Clear? This way. So this 4 was this constant, right? And this 4 is written here, and then this 4 minus 1 is done. Hope it is clear. Yes. Then coming to next term, which is minus 3 x raised to 3. So multiply minus 3 as it is, x raised to 3, so that would be 3x raised to 3 minus 1. Okay, n minus 1 we have to do, plus now this 5x square, so its derivative, so 5 constant number as it is would be written, and x square, so it is 2x raised to 2 minus 1. Understood? So now we have to simplify it. That's it. So I will write my dy by dx as 4 4s are 16, x raised to 4 minus 1 3, minus 3 3s are 9, and x raised to 3 minus 1, which is 2, plus 5 2s are 10, x raised to 2 minus 1, which is x raised to 1, and x raised to 1 we write as x only. So this is how we find the gradient of any given curve or any given function. Hope you understood. Keep practicing. We will be doing a lot of other questions based on this. in next video. All the